If the radius of octahedral void is R, wow, and the radius of atoms in closed packing is capital R, fine, derive a relation between R and capital R. Now, it is something like we are saying that what is the radius of biggest atom which can fit within an octahedral void. So first let us make an octahedral void. First let us make an octahedron. This, dears, is an octahedron. Yes, it is an octahedron. And what do we do? Well, it's something like when you draw atoms at the corners. Well, you could take your own happy time, sweet time and do all that. You're welcome to. Honestly, it would need a little more time for drawing it very accurately. But once we do that, whatever is obtained in middle, see, this octahedron is formed because there are atoms here. I'm deliberating drawing them very small, but actually they would be much huger. How huge would they be? They would be so huge that they touch each other. Where do they touch? They touch here. They touch here. Like this. All midpoints they would have to touch. Okay. Something like this. Like this. That way. Okay. That's very, very interesting. Yes, and typical also drawing all this. What I'm drawing is 6 corners of an octahedron. Atoms are present here, and you are supposed and this is an octahedral void at the center. If I just cut along this horizontal plane, which plane? I'll just highlight this. If I cut this along this plane, what will I see? I would see a square. I would see a square. Why? Because it is an octahedron. This has to be a square. And 4 atoms at the corners and all are touching each other. And radius of atoms is capital R. So the entire edge is 2 capital R. Okay. And radius of octahedral void, how would I count that? This, if I fit in a sphere, then this would be the radius of octahedral void. How sweet. So R, and then I have R, and then I have capital R, and I have capital R. Wow. So the diagonal of this would be length of diagonal of this square is edge length root 2. Edge length root 2, thanks to Pythagoras. And that should be equal to 2 times R plus 2 times small r. Oh wow, so that is 2 cancels off. So R times root 2 minus 1 is small r. Okay. And this is what was required. Derive a relation between small r and capital R. Therefore, small r by capital R is root 2 minus 1, which is 0.414. This is the relationship, my dears, between small r and capital R.